Alright, y'all, it's recording. Okay, so this is section 2, topic 7. Section 2, topic 7. And it's called solving linear equations using elimination. Solving linear equations using elimination. Okay, so far I've taught you how to solve linear equations using graphing and by substitution. So this is the third way that you can solve equations using elimination. Okay, they all three work. Graphing's the only one that if your two lines don't cross at a perfect lattice intersection, then you have to guess. But substitution and elimination is always going to give you an exact answer. Okay. Elimination is easiest if your equations are given to you already in standard form. To me, that's the easiest way. Okay. Sometimes, so different methods are easier for the way the problem's given to you, which I had told you before. So let's look at example 1. So my system is 3x plus 2y equals 2. And my other equation is negative 3x plus 2y equals negative 4. So these are both in standard form. Your x's are lined up, your y's are lined up, your constants are on the other side of the equation. Everything's lined up. When you're using elimination, think about it as like you're combining the two equations together, okay? And you want either your x's to eliminate or cancel, or you want your y's to eliminate or cancel. If your constants eliminate, that doesn't help you at all, okay? We're trying to solve for one variable at a time. So, given this problem, if we combine the two equations together, would any of our variables cancel? What? X's, right? 3x minus 3x is 0. So we say they eliminated. When this happens, this is like best case scenario for using elimination. When that happens, this is the method you want to use. It's the easiest. So just thinking about combining the two equations together, whatever the signs are, what's a positive 2y and a positive 2y? 4y. Bring down your equals. A lot of students forget to bring their equal sign down. And then a positive 2 and a negative 4 make what? Negative 2. So the only variable we have is y, so we will solve for y. In this case, we will divide by 4. And y equals negative 2/4 reduces to negative 1/2, or you could say negative 0.5. Since that is a terminating decimal, then it's okay to write it as a decimal. A terminating fraction or a decimal. If it was a fraction that repeated though, like 1/3 would be 0.3333, I would just leave it as 1/3 so that you're not rounding your answer. So we know what y is equal to. What do you think you do to figure out what x is equal to? Yeah, so if I know y is equal to negative 1/2 or negative 0.5, just substitute that into either of your original equations and solve for y. It does not matter which equation you plug it into. Do you have a question? It doesn't matter which equation you plug it into. Alright, so I'll just use that top equation. So I know that y is negative 1/2 or negative 0.5. So 3x plus 2 times negative 0.5 or negative 1/2 equals 2. That gives me 3x. What's a positive times a negative? Negative. What's 2 times negative 0.5 or 2 times negative 1/2? It's going to be negative 1. And that equals 2. Then we'll just add 1 to both sides. And 3x equals 2 plus 1 is 3. Divide by 3, and x equals 1. Have I solved for x and y? Yep. So my solution, write as an ordered pair. This time we solved for y first. That does not mean that's the first number we write in the parentheses. You write it as an ordered pair, which means it's x, comma, y. And I'm going to write it as a fraction. So let me go ahead and go back and write some kind of directions here. So everybody finished writing up to this point? So I'm going to slide it back up. Okay. So up here, I'm just going to say eliminate. In parentheses, I'll put cancel the terms with x combine like terms and solve for y. And then down here, substitute y equals -1/2 or -0.5 or 5/10 into either original equation, then solve for x. And then write your answer as an ordered pair. I'm going to write that by the solution. So that problem is best case scenario for using elimination. It's not always that easy. You're not always going to have either your x's cancel out right away or your y's cancel out right away. Sometimes you got to do a little bit more work to make them cancel out. Okay, so is everybody finished writing this, what you need from this example? Anybody have questions so far? All right, example 2. We're still going to solve using elimination. So my system is -3x plus 2y equals -6. And then I have -6x plus 8y equals -12. Are my x's going to eliminate? No. Are my y's going to eliminate? No. And it doesn't matter about the constants, but they won't, but it doesn't matter if they did. So what I'm going to have to do, you know how when we clear the fractions, we multiply every single term by the same number? And that does not change the meaning of the equation, right? So we're going to kind of use that same concept, but we're not clearing any fractions here. We're going to see if we can multiply one equation or both equations by the same number in order to create a term that will eliminate one of the variables in the other equation. So look at my x's. Can I multiply 3 times something to get 6? What could I multiply by? 2. But I would need one of these to be positive. So if I multiplied this negative 3x by negative 2, that would turn it into positive 6x, which would cancel with negative 6x, right? So they're both negative. Something's got to be positive. So you would need to make sure you change that to positive 6x. So I can multiply every single term in the top equation by negative 2 if I wanted to eliminate my x's. If I want to eliminate my y's, which that's fine as well, could I multiply 2 times a number to turn it into 8? If I did negative 4 times positive 2, that would give me a negative 8y, which would cancel with this positive 8y, correct? Okay, it doesn't matter if you choose to eliminate the x's or the y's. Sometimes one's easier than the other, okay? In this case, they're both going to take the same amount of work. So I will just go ahead and get rid of my x's. So I have to make sure I multiply every term by the same number. So I'm multiplying every term, this whole entire thing, even on the other side of the equal sign. A lot of kids forget to go across the equal sign. And I'm getting rid of my x's, or trying to, so I'm going to multiply every term by negative 2. Only in the top equation. Sometimes you have to multiply both equations by some number, but in this case, we don't. So negative 2 times negative 3x is positive 6x. Negative 2 times positive 2y is negative 4y. Then don't forget your equal sign. Negative 2 times negative 6 is positive 12. Now in this case, the bottom equation doesn't have to be multiplied by anything, so I'm just going to rewrite it so that everything lines up and I don't confuse myself. Now notice my x's will eliminate, which was my whole goal. So 6x minus 6x is 0. We say they eliminated. Negative 4y plus 8y is positive 4y equals 12 minus 12 gives me 0. Solving for y, so I'll divide all terms by 4. And y equals, what's 0 divided by 4? 0. A lot of kids say, oh, you can't do that. What am I supposed to do? What's the answer? You can, if 0's in the numerator, you can do that. 0 divided by any number besides 0 is 0. What if 0's in the denominator? Can you do that? No, that's when it's undefined. But if it's in the numerator, then it just reduces to 0. Am I finished? I have to find the x. So either you use either original equation, or when I distributed that negative 2, these two mean the same thing. This is just kind of like a reduced version. So any equation you want to use is fine. All right, so I'll just use negative 6x plus 8y equals negative 12. And wherever I see a y, I will substitute in a 0. So negative 6x plus 8 times 0, that gives me 0. So basically I just have a negative 6x on the left and a negative 12 on the right. Solve for x, I will divide each term by negative 6, and x equals positive 2. So my solution is when x is 2, y is 0. And I'm going to make a little note up here. None of my variables automatically eliminated. So I had to multiply the top equation by negative 2 in order for my x terms to eliminate. Sorry, I squeezed that in there. And like I said, sometimes you have to multiply both equations by some number. Now, a lot of students get confused because they're like, where did you come up with a -2? How do you know that number? Well, you just got to think. What could I multiply these by in order to get it to eliminate either the x's or the y's? Like, you come up with that number. It's not some magic number that I looked at the equation to figure out. I did look at the equation to figure out what I needed. But that just comes from you thinking about it. What could I do to get these to eliminate? And again, if I wanted my y's to eliminate first, I would have multiplied the top equation by -4. So that would turn this into a -8y. Either one's fine. Our math will be different, but we'll get the same answer in the end. Yes?
Could you also divide the bottom line?
You could. Yep, you could do that. All right, everybody cool? Example 3. For x minus 4y equals 0, and 8x minus 8y equals -8. Okay, are either of these terms going to cancel automatically? No. If I want my x's to cancel, I would multiply the top equation by what? -2, because -2 times 4x makes -8x, which will cancel with +8x. If I want my y's to eliminate, I would multiply the top equation by -2, because -2 times -4y would give me a +8y, which would eliminate with a -8y, correct? So either way, I've got to multiply by -2. Okay, so I'll multiply my whole top equation by -2. Distribute to every single term. -2 times 4x is -8x. -2 times -4y is +8y. Equals -2 times 0 is 0. Now the bottom equation, I don't have to multiply by anything. So that's 8x minus 8y equals -8. Okay? So now I will combine like terms. -8x plus 8x is 0. +8y minus 8y is 0. So what am I left with on the left side of the equation? On the left side. So 0 equals 0 minus 8 is -8. All of my variables canceled, and am I left with a true statement or a false statement? A false. So I already know my answer. Does anybody have any idea what it is? No solution. Your variables all cancel and you're left with a false statement. The answer is no solution. So if we would have graphed these, any idea what the graphs would have been? No solution means they never intersect, so it would have been two parallel lines, right? If we would have solved by graphing, we'd have gotten two parallel lines. If we solve algebraically, no solution means your variables canceled and you're left with a false statement. Coolio? Anybody have a question? Okay. Example 4. 5x plus 6y equals 4. 10x plus 12y equals 8. And if your questions are given to you and they're not both in standard form, you can convert them to standard form, or if the variables are lined up, then that's okay too. Okay, all of the ones that we've had, they've all been in standard form. Do any of my variables eliminate automatically? No. So top equation, sometimes you multiply the bottom equation. Sometimes you have to multiply both equations. But in this case, it's the top equation again. What would I multiply by to if I wanted my x's to eliminate? -2. What would I multiply the top equation if I wanted my y's to eliminate? -2. So -2 it is. So top equation, -2 times 5x is -10x. -2 times positive 6y is -12y. Don't forget to write your equal sign. -2 times positive 4 is -8. The bottom equation, I don't have to multiply by anything. So that's 10x plus 12y equals 8. All right. The x's are going to eliminate. The y's are going to eliminate. The constants are going to eliminate. So what do I have on the left side of the equation? 0 equals, what's on the right side? 0. Is that a false statement? No solution? That's a true statement. No variables, but a true statement. What do you think the answer is? Infinitely many solutions. So if we would have graphed these, it would have been two lines that are the same line. Now, next class I'm going to teach you how to graph solve 3 equations that have 3 variables in each equation. But before we do that, we're going to do a word problem. Okay? So example 5 will be a word problem. Each morning, Darnell, yes, I got this from Algebra Nation, does a combination of aerobics and stretching exercises. Period. The exercises burn different amounts of calories per minute. Period. The following system represents the time Darnell exercises and the amount of calories burned. Period. In the system, comma, X represents the number of minutes Darnell spends doing aerobics, and Y represents the number of minutes he spends stretching. Okay, so look at those equations. If X is represents the number of minutes Darnell spends doing aerobics, and Y represents the number of minutes he spends stretching, what do you think X plus Y equals 60? What's that talking about? The number of X is the number of minutes he spends doing aerobics. Say it again. Yeah, how long is he exercising? Number of minutes doing aerobics plus number of minutes stretching equals 60. That's got to be talking about the number of minutes he exercises, right? Literally, I spelled exercises. E-X-O-R. E-X-E-R-C-I-S-I-N-G. Number of minutes he spends exercising. So what do you think 15x plus 5y equals 500 means? Go back and read the question. The calories, right? It says each morning Darnell does a combination of aerobics and stretching exercises. The exercises burn different amounts of calories per minute. The following system represents the time Darnell exercises and the amount of calories burned. So 15x, what is that 15 talking about?
15 calories per minute.
Of doing what? Aerobics. So that's, he burns 15 calories a minute doing aerobics, and he burns 5 calories per minute while stretching. So this equation represents the number of calories burned. So a lot of times you'll be asked to set up those equations on your own. Okay, in this problem they set it up for you. So we're going to use the elimination method to solve the system and determine the number of minutes Darnell spends doing each exercise. Okay? Because we know he burned a total of 500 calories and that he worked out for 60 minutes, right? So we're going to figure out, okay, well, if that's the case, how long did he do aerobics and how long did he stretch? So we'll have to solve for X and Y to be able to find that out. See what I'm saying? Okay, so if I want to eliminate my X's, we can see X's and Y's don't eliminate automatically. So if I want to eliminate my X's, I would multiply the top equation by what? Negative 15. And the bottom, If I wanted to eliminate the y's, I would multiply the top equation by -5. Does it matter which one I do? No, to me, if I multiply by -5, it's just a smaller number, right? So that's the one I would choose because it's a smaller number. But I could easily eliminate my x's. That's fine as well. So I will eliminate my y's by multiplying the top equation by -5. So -5 times x is -5x. -5 times positive y is -5y. Don't forget your equal sign. And -5 times 60 is -300. The bottom equation, I don't have to change anything, so I will just rewrite it like it is, line it up under my new top equation. And combine like terms. So -5x plus 15x makes 10x. -5y, positive 5y, eliminate. Don't forget your equal sign. -300 plus 500 is 200. Solving for x, divide by 10, and x equals 20. So remember, x stands for the number of minutes Darnell is doing aerobics. So how long is Darnell doing aerobics? 20 minutes. So we know if he's doing aerobics for 20 minutes, how long must he stretch? 40, because altogether he worked out 60 minutes, right? But we're going to go ahead and solve that. So I will just use that top equation because that's just looks like it's easier. Again, it doesn't matter. So if Darnell stretches for, does aerobics for 20 minutes, plus the time that he does stretching, that means he must be stretching for 40 minutes. Of course, it's a word problem, so I'm going to answer the question with words. The question says, in the system, x represents the number of minutes Darnell, we didn't actually write the question down. I just said it out loud. So I'm just going to say Darnell spends 20 minutes doing aerobics and 40 minutes stretching. And then of course I could substitute those numbers in and figure out how many calories he burned doing aerobics and how many calories he burned stretching. Everybody cool with that? Do we need to see another example, or you feel like you got it? You got it? Okay. Well, we'll pause the video.